learn so much just from watching Superman fly. For instance, we could learn the force of the Earth on Superman himself by multiplying negative 9.8 newtons by 113 kilograms, which is Superman's weight, to find that the force of the Earth on Superman is negative 1,107.4 newtons.
Unfortunately, Superman missed his flight. He's left to his own devices and uses Nikes with springs to be looking fresh. Speaking of which, I wonder what an LOL chart for Superman would look like during such a complication. We must determine which forces and energies are being displaced. Thank God we've been taught physics by the smartest physics teacher in the game. But oh my God. On his way to the engagement, Superman got distracted and he hit a building. Let's find the force of Superman hitting a building. We can find this by multiplying Superman's mass by his acceleration.
But to find his acceleration, we need to calculate his final velocity first. If there's 5,560 miles between Paris and San Francisco, and it takes him 5 minutes to travel that far, then his final velocity will be his displacement of 5,560 miles divided by his time of 300 seconds.
We can find Superman's acceleration by using his final speed, 18.54 miles per
second,
subtracted from his initial speed of 0 miles per second, divided by the time it took, 5 minutes. 18.54 minus 0 divided by 300 gives us that Superman has an acceleration of 326.3 feet seconds squared. And when we plug this information to the force equation, we find out that
the force is 11,238.56 newtons, which is around 2% of the force exerted by a car on a wall. Oh my God. Superman, watch out. There's bad guys with guns. Speaking of which, I wonder what the force of the bullet is against Superman. Thank God we know so much about physics. Thanks, Magary. If we're given the acceleration of the bullet is 440,000 meters per second squared, then we can multiply that by the mass of the bullet to find the force. Therefore, the force of the bullet is 418,000 newtons.
You may be wondering, could Superman break the sound barrier? Since Superman's top speed is over 3,218 kilometers per hour, and since sound waves travel at around 770 miles per hour, Superman would just have to reach the speed of 770 miles per hour just to break the sound barrier.
So in short, Superman could break the sound barrier whenever he wanted. And that's it, folks. What an incredible year of learning physics, especially Superman-related physics. I want to thank you all for listening to our presentation, and I hope you all have a wonderful day.